Hello, can everybody hear me? Let's see. All right, if you all see me, give me a heads up. So go ahead and put your name down just so I can take attendance to see who's here. So if you can just like type something in the chat, I will I can see you. Oh, it's like an infinite loop. Sweet, so just let's give it another minute and then we can start in just a sec. Okay. So thank you all for doing this for me. So I'm actually traveling, so I'll be here for the next week. Um, if there are any questions or concerns or anything, just free to email me or just leave a chat box and I will try to get to it as I see it. It's kind of hard without you guys' feedback, so I can't really see what's going on and what I'm missing or whatever. So just in terms of how we're doing in terms of the semester, so I finished grading the midterm. I just need to look through it a little bit and go back and see how people are doing. But overall, people did pretty well. I think the average was a 79%, so pretty high. And then I gave a couple extra bonus points to just, for grading purposes, etc. So I think that brought the average to be around an 80. So I will upload grades and stuff tonight, and then you will review them on Thursday. Okay, so if you have any questions with that, we'll talk about that on Thursday. So just hold your midterm questions until then. Let's see. So what I thought we could do today was kind of finish going over Chapter 7 and do a couple of activities regarding Chapter 7. So if there are any other outstanding questions, go ahead and type them in the chat box and let me know. Otherwise, let's try and plan on doing this for today, and then we'll do the same thing on Thursday as well. So today should be a pretty short lecture because we're just going to kind of review what we did last time, and then I'll just stick around on the YouTube Live to kind of hang around for questions if you have any. Okay, so let's see. I don't see any feedback, so hopefully you all like this because you don't have to come to class early on Tuesday. And I know it's Halloween, so I'm sure people want to go home and get ready for their Halloween events tonight. Okay, so where we left off with Chapter 7. So if you all see let's see if that's sharing, my Chapter 7. So this was our part 1, right? So where we kind of left off was really, can we do hypothesis testing correctly, right? And so can we frame our hypothesis in the right way? Do we have the claim correct? Do we have the direction effect? Right? And then when we have some sort of conclusion, depending on our p-value, what does the p-value tell us? And at the same time that we have statistical significance, or if we're determining levels of significance, we also have to determine whether the level of effect, right? So our effect is something that we've discovered, is that truly clinically significant, or is it meaningfully significant? So that's the whole point of an effect size. So that's what we covered with our Cohen's D statistic. So this is all from part 1 of Chapter 7, right? So it's measuring that size of the treatment effect in terms of the standard deviation changes, right? So our mean difference over our standard deviation tells us whether our magnitude is large enough to determine if this is a meaningful difference, okay? And here are just some guidelines for what we think a strong effect size is going to be, okay? And so that's the whole point of reporting our effect size. Okay, so we've kind of covered like what and how hypothesis testing works. And so I didn't really test you too much of this on the midterm. This was more of just like, can you understand some of the terminology? Okay. Hold on, people aren't getting, yeah, so I'm not going to be sharing any video just because I'm not dressed. So I don't look like how I normally look in class. All right. So this is what we're going to start off with for the rest of this. So this is actually, let's do this in. So let's continue with this in terms of the part 2 of Chapter 7. So let's run this in an actual test. So we kind of started with this last time, which I unfortunately did mistakenly. So the key concepts of what we're doing is this is going to be Chapter 7.4 and 7.5, right? So these are the methods for testing a claim about a population mean, okay? And there are instances where we might not know the standard deviation, which we've already seen. And when we do know or versus when we don't know, there are different tests for which test that we can perform. All right. So initially, if we have a known standard deviation, so this is for Chapter 7.4, our test statistic is going to revolve around using our Z statistic. This is our formula here. that we can see, which is our z is equal to our mean of our sample minus the mean of the population we're interested in testing over its standard deviation divided by the square root of the sample size that we're interested in using. Okay, and to determine whether something's statistically significant, we'll use our critical value method, which is the z-score table, which we can look up to see whether our value exceeds the critical value. Okay, and if it's truly statistically significant, we can say if our value is beyond that value, then yes, this is a statistically significant result. Around. Okay, and then we can convert that to our p-values. In 7.5, to when we don't know the standard deviation. Right, so this is using mean minus the population mean over the estimated standard deviation, which comes from our sample root of n. Okay, and in both instances, which we do, instead of using our z table, we move to using a t table. Okay, and so we gave you those z and t tables for your midterms last time. All right, so that's how we look at those tables. So when we're testing a claim about a mean, if we know that population standard deviation, when we know this, we use that test that involves knowing what our normal distribution. And I think I've said this before. It's like in reality, it's the true population standard deviation, because like if you already know the population mean, why wouldn't you know the population standard deviation? So for the most part, you probably, or you would know mean. All right, so in instances where you do know, right, for 7.4, we can test our mean for our sample using the z statistic. Okay, so for instance, so I think we did this example last time, was that where we list them below, this measure of radiation in watts per kilogram corresponding to a certain sample of cell phones. So I've asked you to use a 0.05 level of significance to test the claim that cell phones have a mean radiation less than 1 watt per kilogram. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cell phones that we've collected here, and I've told you that the mean of this sample is 0.938, and the overall population standard deviation is 0.48. So this is saying of all ones that this sample comes from, the known population standard deviation is 0.480. Okay, so that's why it's denoted by our sigma here, right? It's a known population standard deviation. Okay, so now let's go to our steps to make sure that we're doing this test correctly. Okay, so step 1, right? We're expressing this as a claim that says that the mean radiation level watt per kilogram. So we'd express this as the mean being less than 1 watt per kilogram, right? So that's what we're trying to prove, right? So that's what we're trying to prove. That's our hypothesis of interest. Okay. Step 2 is therefore going to be our counterclaim, right, to the original claim. So it's going to be in the opposite direction, or in the opposite effect. So the counterclaim is, we'd say that the mean is greater than 1 watt per kilogram. Okay, so then we can just write these hypotheses as both null and alternative, right? So our null being that the mean is equal to 1 watt per kilogram, or you could also say the mean is greater than or equal to 1 watt per kilogram. That's our null hypothesis. Whereas alternative, which is what we're trying to prove, is that the mean is less than 1 watt per kilogram. Okay, so those are our two options for writing our null and our alternative hypotheses. Okay? So remember, this is what we denote as a one-tailed test, because, right, this is a directional effect. We're interested in proving that the mean of the cell phone radiation is less than 1 watt per kilogram. Okay. So in step 4, we've told you that the stated level of significance is alpha of 0.05, right? So that's already kind of given to you in this instance. But in most times, you'll want to set a level yourself, right? So usually it's 0.05, it could be 0.01, it could be 0.02, it can be anything, right? But for the most part, it should be either given to you, or you should assume that it's going to be an alpha of 0.05, because for the most part, we're okay with a type 1 error, right, which is what the alpha is, of 0.05. So if there's any lag, this is recorded, so I'll go ahead and post this after. So if you can't hear me right now, it'll be posted as well again after. But just make sure you're following the slides. And if you have any questions, go ahead and ask them in the chat box. All right. Okay. So we said that, okay, because the claim is about our population mean, right? So the statistic most relevant to this test is going to be our sample mean, right? So we're going to just use our X bar, which should represent the true population mean. And then we go ahead and calculate the test statistic in our step 6, and then we can go ahead and find the p-value and the critical value using our z-table, right? So let's just plug in chug for the most part, right? So we have a sample mean, which was already given to you, 0.938. We're using it to test the population mean of 1, right? So -1 over our known population standard deviation of 0.480 divided by the square root of the total sample size of what we're collecting, which is 11. So that's negative 0.43, right? So that's our test statistics, or our z statistic. That's what we're using to calculate to determine whether our sample is truly different from our population mean. Okay, so if we go ahead and look at our z-table, we find that the critical value is negative 1.645. Because remember, we said this is a one-tailed test, so we just go ahead and look directly for an alpha of 0.05. So we can look within the table to figure out what the z-score will be on the outskirts, right? So for this, we're looking on the inside to determine what the value of the z statistic should be, right? So we go ahead and look for 0.05 on the inside, and that corresponds to negative 1.645 on our z-table. Okay, so our z actually falls within the critical region, right? So it's not more extreme than what we would expect, right? So we're just saying, is our z that we calculated, right, this 0.43, more extreme than this 1.645? And it doesn't. Okay, so in that case, we would fail to reject the null hypothesis. Okay, so that's our conclusion for this so far. We fail to reject our null hypothesis. So the other method that we can do, right, so the first method we'd use was the critical value method. This method is the p-value method. So this example refers to a left-tail test. So the p-value is the area to the left of z of 0.43, right? So if we calculate that to be, we can look at the p that corresponds to this negative 0.43. So you can go ahead and find 0.43 on the outsides, on the margins, and that corresponds to a value of 0.3336. Okay, so this value is not less than our significance level that we stated, which was an alpha of 0.05. So because that value is not smaller than it, we fail to reject the null. Okay, so in both methods, both the critical value and the p-value method, both of those should give you the same conclusion, right? So in this instance, the null hypothesis, because our z that we calculated, right, from our previous slide, right, this is not more extreme than what we said that value should be, right, when we look for 0.05 critical value. So this is not, 0.43 is not more extreme than negative 1.645. So in that case, we fail to reject the null hypothesis. Okay, in the other method, in our p-value method, so we found the z that is 0.43, we turn that into a p-value which corresponds to 0.3336. So that's the amount of the area in that corresponds to 0.43. So that value is not less than our stated significance level of 0.05. So because that p-value is larger than 0.05, we also fail to reject the null hypothesis. Okay. So that's our conclusion for that. So are there any questions with our z statistic testing method? So remember, for our z, we know our population standard deviation. We can use two methods to determine whether we can reject or fail to reject the null, right? One is using the critical value method. So we calculate our z statistic. Is our z that we calculate greater than or less than, in terms of more extreme than the stated value that we want to use? Okay. And the other method is our p-value method, whereas is our p that we find that corresponds to the z statistic that we've calculated, is that smaller than our stated significance level? Okay. If they happen to be true, then we would reject the null hypothesis. If that's not true, then we would fail to reject that null hypothesis. Okay. All right. So I think doing examples will actually help, right? So for the next part, we move to 7.5. So this is testing a claim about a mean again, but for this instance, we don't know the population standard deviation, right? So when sigma is not known, we use a t-test instead of the z-test, and this incorporates the student t-distribution, okay? So we're moving on this half of the table right here. Okay, so we can use our critical value method, but we are less likely able to use our p-value method because we have to get the exact p-values, which is more difficult to do because remember what we said about a t-distribution is that it changes, right? It changes as the distribution changes, depending on your degrees of freedom. Okay, so we said that to get our critical value, we use the student's t-distribution with degrees of freedom of n minus 1. Let me put this on one line so it's clearer, right? So our degrees of freedom is drawn from our total sample size minus 1. Our p-values, exact values can't be determined using the t-table, right? So we have to use an exact value method, which we can use using StatDisk, or we can actually do SPSS to determine those. And we'll actually go on using how to do this in SPSS. So let's actually figure out how to do this. So let's do an example. So for heights of parents. So height measurements were collected from the parents of mother and father of 20 males. Okay. So the difference in height for each set of parents is found by subtracting the mother's height from the father's height. So this results in a list of 20 values with the mean of 4.4 inches and a standard deviation of 4.2 inches. So this test is saying, use a 0.01 significance level to test the claim the mean difference is greater than 0. Okay, so we know our directionality, right, because we're saying that this is greater than 0. We know our significance level because it's given to you. And then you can go ahead and test this claim using your mean and standard deviation given to you. So let's do this using the steps that we have from previous lectures. Okay, so for instance, this is our data set, so you don't have to worry about how it's done. I'll just show you this. So the summary of the statistics is that there are an n of 20 with a mean of 4.4 and a standard deviation of 4.2. And I've told you that the significance level of this test is going to be a 0.01, an alpha level of 0.01. So here you can see that you only have the sample standard deviation of 4.2. Right? It's not giving you the population standard deviation. Right? So let's go ahead and use our steps to be able to put this into a form of a hypothesis test. Okay. So step 1, right, is to identify the original claim and put it into a symbolic form. So you can identify within the statements that are given to you is that we want to test that the mean difference is greater than 0. Okay, so from within that, we can see that we are trying to write that we want to test whether the mean, right, the population mean is greater than 0, which is given here. Okay, our counterclaim is the opposite direction, right? So then we can say that our mean is less than or equal to 0. So then step 3 is going to be deciding which one is going to be the null and which one's going to be alternative, right? So our alternative hypothesis is always what we're trying to prove, what we're interested in proving. That's going to be denoted by H1. So usually I write that one first, just saying that the alternative is showing that the mean is greater than 0. And then the null is that the mean is equal to 0, right? So you can write that, or whether that the mean is Oh, one sec. Let's just write this out so y'all can see. You can also show that the mean is less than or equal to 0, right? So let me just copy this. So those are both equivalent ways of writing the same thing. Oops. Let's put that in there so y'all can see it. All right. So those are equivalent ways of writing your null hypothesis, that the mean is equal to 0 or whether the mean is less than or equal to 0 are also the same. Okay, so step 4 is to make sure you can identify our significance level, which was already given to you in this case, right? Is that our alpha is just equal to 0.01. And then your step 5 is just to determine the type of test based on your population parameter and your alternative hypothesis, okay? So then you have your one-tail test, right? You know that it's one-tail because we've tried to prove that it's greater than or less than, right? So it's a one-tail. And then we know that our population mean is an unknown because we don't know the sigma, right? We don't know our population standard deviation. So therefore, we have to use a t statistic to run this hypothesis test. Sorry. Okay. So then for step 6, we can calculate the test statistic, right? And then run our test, right? So t is just given by the mean minus the population mean. So it's 4.4 minus 0 divided by the sample standard deviation over the square root of our sample size. All right, so it's 4.4 divided by 4.2 over square root of 20. So that gives you a test statistic of 4.6851. Okay, so our test statistic is given here. We have to identify what the critical value from our t-table is, right? So we know that the degrees of freedom is 19, and we're looking for an alpha of 0.01 in one tail. Go ahead and actually pull up our t-table. Give me one sec. Let me find this t-table to make sure y'all can see. This is our t-table. Let's pull it up really quickly. So we're looking for a degrees of freedom of 19 and an alpha of 0.01 in one tail. Okay, so this is the same table that was given to you. So we're looking for degrees of freedom 19 with an area in one tail of 0.01. So we're going to go ahead and look in this column here, right, and down the line for 19. So our critical value is 2.53. So that's what we're trying to prove, whether our test statistic is greater than our critical value of no. Okay, so our critical value, right, is our t is here drawn by 2.538, but our test statistic is much greater than our critical value here. So 4.68 is greater than the critical value of 2.539. Okay, so this falls within the rejection region, so we can go ahead and say that. We can draw the conclusion. We say that because the test statistic is within the rejection region, we reject the null hypothesis. So because the test statistic does fall in the rejection region, we reject H naught, or the null hypothesis. Okay, so those are your steps for running your t test using a sample compared to a population mean if you do not know the population standard deviation. Okay. Okay, so that was our critical value method, right? So we found the critical value using our degrees of freedom and whether our test statistic was greater than that. And then like the other method that we use for our z statistic, we can use the p-value method to determine if this can be rejected as well. So here we can say, do the same thing, right? We have step 1, step 2, and step 3 are the same, where we have to identify the claim and put it in a symbolic form and show that the mean difference is greater than 0. Counterclaim is that the mean is less than or equal to 0. And then we can go ahead and write our null and alternative hypotheses. All right, same here. Okay, our significance level is the same, and then our step 5 is also the same, right? The test is the same direction. It's a right-tailed test, and then the population mean is the test that we're doing with a unknown population standard deviation. Therefore, we have to look at a t-table. And then for this, oh, I think I moved a slide. But what we can go ahead and do is actually what we do at the end of this is actually input this into SPSS or StatDisk, and then we can find out whether the value is less than the significance level of interest, right? So if our p-value happens to be, 0.0001, which is less than our significance level, then yes, we can reject the null hypothesis. If this value is greater than 0.01, then we would fail to reject the null hypothesis. Okay, so those are ways of doing our null and alternative hypothesis testing for means. Okay, so we can hold off on those other 2 slides because I want to make sure we're understanding these. So does that make sense for people so far? So this is building off on what we'd seen before from part 1 of chapter 7. And then now we're actually running the true test. Okay. All right, so questions, let's see. So yeah, this is recorded, and then I'll just post it after we're done. So it's going to be for your viewing pleasure after. So I know it's kind of abstract until you actually do it. So we can do an activity, if that's okay with everyone. Yes, no? No, yes, okay. So let's go ahead and open up the, let's see, where's my, so let's go to our week 10. And there is 2 activities. So one is just some practice. So you can go ahead and run that yourself. But let's do the SPSS activity right now. And I'll leave the other activity for you all to do on your own. And you can do that for practice for yourself. And I'll upload the key. But I really want to get to the SPSS activity right now, at least. Okay. So we can actually do a lot of our one sample t-tests using SPSS because, for the most part, software makes this much easier to do than, running all these calculations by hand, like you've already seen, and then determining which method you have to use. So it might be just easier overall to just use SPSS. One of the problems with, or not problems, one of the things with SPSS is that it's difficult to do a one sample z-test using SPSS. Because like I said before, is that in the real world, for the most part, you're not really going to know the population standard deviation. So what happens is SPSS will just give you the t-test estimate of the z-test, right? And so we said this last time, right? So as your, I don't know how to open, but as your degrees of freedom gets larger, right? The larger that gets, the more closely it approximates the z distribution, right? So the larger your sample size, the more likely it'll look like a z-table. So let's go to the t-table here, right? So we saw that if you have, let's say, here's our area in 2 tails, right? So this area in 2 tails of 0.05. So this value, right, is getting smaller and smaller as your degrees of freedoms gets larger. Yes, in this left column gets larger, it gets smaller and smaller. So you see that as this gets large, this is 1.96. So if you go ahead and look at this up on a z-table, this actually equals the same value as the z for an alpha of 0.025, right? So they are equal if you have a large sample size. So that's why in SPSS, they don't do the z test built into that. Okay. All right, so let's pull up this activity. So go ahead and try to open up, I don't know if you all have SPSS with you, or you can go ahead and use the Beach apps. So that's probably the easiest thing to do. That's what I'm using right now because I don't have SPSS on this computer. So the activity, I will actually make it due by the end of today, by the end of the day, so I'll say midnight tonight. So I'll give you some time, but let's just go through one activity or one or two questions, and then you all can do the rest on your own and then submit that for your activity assignment. And then we'll call it a day for today. Okay. I'll change the due date on that for the Dropbox. So let's see, this is activity 1. Okay. So let's do this one together. So we have a principal wonders if her 5th grade scores differently on a math test than 5th grades in the US at large. So we know that we have that you have a sample of 20 5th graders from her school, and she knows that 5th graders in the US at the large have a mean of 88 on her test. Just submit the SPSS one, and then you don't need to output anything from SPSS into the activity to do it. All right, so I'll let you all run that. If you can't get SPSS working, let me know. Do the other activity and submit that. That's fine too, okay? So I just want to have something for your record of attendance. And if you still have questions with SPSS, you can email me. All right. All right, so let's actually go through this example together. So we know that we're testing the population mean of 88 on the test, and then we have a sample of 20 5th graders. So we have these sets of scores here, so on and so forth. So we're interested in testing whether the mean, right, is equal to 88 or whether it's not equal to 88, right? So here we know that it's a two-tailed test because we don't have a directionality of the effect. Hold on, let's see, there's a couple questions. So let's make sure we're doing this. Okay, so let's clear this up. Okay, so do the SPSS with me right now if you are able to. If you cannot get SPSS working, I'll give you till midnight tonight to submit it and make sure you can get it in. If you aren't able to access SPSS by tonight at midnight, go ahead and do the other activity, which is similar things, but you're going to just do a lot of the questions by hand. There's fewer questions, but you're just going to do these ones and submit that. I'm just using this to track attendance. So don't worry about it too much if you can't finish it tonight, but just make sure you do it at some point. All right. But let's get through this to make sure we're understanding how SPSS works. All right. So what we're going to go ahead and do is just type in our values for our data sets. So I'm going to have to do this. Let's see if I can do this easy. So I have this. Oh no, I got kicked out. Let me log back in. That's going to load. Okay, so now I have SPSS loaded on here. Okay, so there are those 20 observations that are given to you in that data set there. All right, so let's go ahead and type those values in for the test scores of our 5th graders. Okay. Okay, so these are our test scores that we obtained for our 5th graders, right? So I went ahead and typed those all into our SPSS window here. So we see 20 observations. So what we're going to go ahead and do is go ahead and hit our Analyze button. We're going to go to Compare Means, and then we're going to go ahead and hit One Sample T-Test. So that's pretty easy, right? So we go ahead and drag the variable that we want to test. Oops, let's cancel that. Over. And our test value we said was going to be 88, right? So let's go ahead in options to make sure we're running the correct options. So our confidence interval percentage, we're just going to leave as 95, right? So remember, if I don't tell you what the level, yeah, sorry, go ahead and I'll give you a second. So let me make sure you're typing. Let's just give me a heads up when you've finished typing. So I'll go over this again. Yeah, sorry, I was going too quickly. So go ahead and just give me a thumbs up or a emoji. Do I have emojis on here? All right, so it seems like a majority of you have input your data. All right, so you've typed in all 20 scores that you have from your fifth graders. All right. Good. Stop me if you're lost. But so you've typed it in. Go ahead and click Analyze. You're going to go ahead and click Compare Means. And then we know we are doing a one sample t-test, right? So we're comparing our sample mean to the population mean. Go ahead and click that. Does, all right. So we go ahead and drag our variable in. So for this, I didn't get to name my test variable, but like we've done before, you should always name your data sets appropriately. And we know we are going to test a test value of 88, okay? And then you can go ahead and click options just to make sure you're doing everything correctly. So your confidence interval percentage is actually the same thing as your p-value that you, or your significance level that you're setting, right? So a 95% confidence interval is corresponding to a 0.05 significance level, right? So if I told you to test at a 1% significance level or a 0.01, you would go ahead and change this to a 99. All right, but for now, since we're going to just go ahead and run this test at a, I believe this was 0.05. Let's make sure. I don't think I told you, so if I didn't tell you, you can go ahead and keep it as a 0.05, right, which is a 95% confidence interval. So go ahead and just click Continue, and then OK, and that's it. And so that will run your test, right? So this is our one sample test. Oh gosh, I can't see anything from here. So we can make this bigger. Maybe it'll resize it. Let's see, maximize. Yes, all right, so we actually can see this. Cool. Perfect. All right, so what this goes ahead and gives us is a couple of different things. So first it gives us, nicely, it gives us our sample statistics. So in the first set of data, we have our n, which we told you that it was 20, right? You typed in 20 sets of data. You have its respective mean, and you have its standard deviation, right? And you have the standard error of the mean. So this is just the summary statistics of that variable that you gave. So this isn't anything new. You can go ahead and do this for anything that you've done before, right? You can use it using your descriptive stuff that we've learned in previous classes. So this isn't anything new. What you get that's new is in this part down here in this one sample t-test, okay? So it gives you a couple of different things. So you can actually test your a couple of different ways here. Okay, so we've covered the critical value method, but what we didn't cover was the confidence interval method. And so I'll go over that in this example here. Okay, so here is just the t-statistic in the first column here. So the t-statistic is what you get from using the formula that we've seen before, right? Which is just going to be the sample mean minus the mean that we're trying to test divided by the sample standard deviation over the square root of n. Okay, so that's what you get for your t-statistic. Okay, so that's just calculated using these values from up here, which you've already seen. So you can solve this value using the values from your one sample statistics, right? Because that's just going to be the mean here minus 88 divided by this divided by square root of 20. That's how you get your t. Okay, your degrees of freedom you've seen before, right? That's just going to be n minus 1, right? So 20 minus 1 gives you 19. All right. The next thing that you get is what's called the sig, or that's the actual p-value of interest, okay? So the sig is the two-tailed test for your test that you've run, right? So the sig is telling you that the p-value is 0.544. So this value is going to be what you compare to the significance level that you set. So we set our significance level at 0.05. Okay, so is this less than or greater than the significance level that we set? So go ahead and type in what you think. Cool. So it seemed like most of you had said that this is going to be greater than, right? So 0.54 is greater than the significance level of 0.05. So because that is true, that's saying that we would fail to reject the null hypothesis. Okay, so because our significance level or p-value is greater than the significance level that we set of 0.05, we fail to reject the null hypothesis. Okay, so that's the p-value method. Okay, so the critical value method is kind of a mix of things that we have to do here, right? We have to go ahead and look at the t value here, right, that we calculated, but then we have to go back and compare it to the t statistic that we get from our table. Okay, so we compare our negative 0.618 to the value for a 19 degree of freedom test for our 0.05 level here. So we go ahead and look at our t-table. Let's go back to our t-table. We see that we're looking for an area of two tails of 0.05. And then here we can go for 19 degrees of freedom and find that the critical value is 2.093. So here, our test statistic is less than the critical value, right? So our test statistic was negative 0.618, less than the critical value of 2.093. Okay, so because that is true, right, because it's less than that, we fail to reject the null hypothesis. Right, so in both instances, both the p-value method and the critical value method, we fail to reject the null hypothesis. Okay, so hopefully that makes sense, is that in the critical value method, you're trying to see if your test statistic, right, so the t that we get here, is this going to be more extreme than the critical value that's given on your t-table here? Okay, is your value more extreme than the value that's given on the table here, depending on the degrees of freedom? In your p-value method, what you're trying to see is your sig or your p-value in this column here, is that going to be smaller than the stated significance level? Okay, so both methods are appropriate, but it just depends on which one you like to do. Okay, so I think for when you're using SPSS, the p-value method is a lot easier to use, right? Because you just go ahead and look for whether this is going to be less than your stated significance level. Okay, so then the last thing that we have is the 95% confidence interval of the difference. Okay, so the mean difference is what we are interested in looking at here. So the mean difference is just going to be the value that we get for our sample mean minus the stated mean that we're trying to test. So that's just going to be this 86.65 minus the 88. Because remember, we're testing the difference of 86.565 to 88. Okay, so that's where you get this mean difference. So this is just negative 1.35, which is just 86.65 minus 88. We also get the confidence interval of that difference, right? So we're saying, what's the potential likely values of the true population difference between our sample mean to our population mean? Okay, and we can go ahead and put a confidence interval on it, right? We've done that before. We've put confidence intervals on means. We put them using the mean, and then we go ahead and divide that plus or minus the margin of error, which is just our standard error for the most part, right? And we can do the same thing using this mean difference value as well, right? So it's just the mean difference plus or minus some margin of error. And so doing that, we get the value could exist between, right? So the 95% of those confidence intervals are going to be between negative 5.92 and 3.22. Okay, so because the mean difference could potentially fall, right, from negative 5.2 all the way up to 3.22, that says that the difference between the sample mean and the population mean could either be negative or it could be positive, right? So because it's both negative and positive, because of all those possible values that go between negative 5.92 and 3.22, that means that the sample mean could either be greater than the population mean, or it could also be less than the population mean. So therefore, we also fail to reject the null hypothesis using our 95% confidence interval method. Okay, so does that kind of make sense? So what we're doing is saying that if our mean difference is both negative and positive, we don't know whether it's going to be above or below the mean. Okay, if both of these signs were both negative, if this was negative and this was negative, we'd say that we're 95% confident that the true population value is going to be negative, right? It's always going to be less than the value between the sample and the population. If this is both positive, that means that we're always certain that the sample mean is going to be greater than the population mean. So that's how we use the 95% confidence interval to test the differences between our sample mean to our population mean. And that's what's highlighted actually in the last two slides of the lecture, right? So they're highlighted using the confidence interval method here. See if it helps clear up a little bit more. It's just if both of the signs are in the same direction, so if these are both negative, you can fail to reject the null. Or sorry, if they're in opposite directions, you fail to reject the null hypothesis, right? Because you don't know whether the sample mean is greater than or less than the mean. If they're both in the same direction, then you can go ahead and reject the null hypothesis. Okay? So what is failing to reject the null hypothesis? So in all three cases, using our T critical value method, and as well as our confidence interval method, we said we failed to reject the null hypothesis. So why don't you all go ahead and type me a statement and tell me what conclusion about our test scores. And I know the answer is there, but all right. Am I losing you all? All right. So for all three ways that we've done this, we've failed to reject the null hypothesis. So that says that the test is not statistically significant. Okay. So then our conclusion is that fifth graders from the school do not differ. Exactly. Yeah. So that's a perfect answer. So we fail to reject the null hypothesis, and we can say that the fifth graders from our school do not differ in their performance from the overall population mean of 88. So the other way of saying that is that the test is not significant, and we don't have evidence whether we know that the fifth graders from this school perform better or worse than schools on average. Okay. So that's basically using SPSS to run our one sample t-test. Okay. So why don't you all go ahead and run the rest of these. I'll hang around on YouTube chat if you have any questions. So other than that, just do that and then submit that, and then I'll reopen the Dropbox to make it due at midnight tonight. Okay. So I'm just going to mute myself, but if you have any questions, go ahead and type them in the chat, and then I will either respond in the chat or will just respond on the actual channel. All right. So you don't need to submit anything onto this for. You don't need to submit anything from SPSS or this. So just go ahead and you can type in the value. So I kind of made tables for you already. So you can just type in the ends, the means, the standard deviations, etc. And then I want you to be able to draw conclusions based off this. So this is like what you'd see on a quiz or a test, right? Is that given some of this SPSS output, can you understand what this test is telling you based off whether you fail to reject or reject the null hypothesis and what that real conclusion is going to be. And in clarification, just do the SPSS activity. The other activity I'm just going to leave for you all. You can do it and I'll upload the key. That's just for your practice.